And that happens at 10, 20. So what we need to do is come up with, and it tells us, the slope of this line is equal to 5. So the slope of the linear part so far we know for this function that when x goes from 0 to 10, it's on this cubic parabola, and they gave you that equation in the problem. The equation was ax cubed plus bx, and that's when x is between 0 and 10. They did not give you the equation of the line. The only thing they told you was the slope, and you also know a point on the line, the 10, 20. So with the slope and a point, you can write the equation. To write the equation, you need to know the slope and the y-intercept. Well, we know the slope's 5, we're just missing the y-intercept. We can find the y-intercept by plugging in the x and the y in for these values. So the y is 20, the slope was given as 5, and the x is 10. So if that's 50, if I subtract 50, b is going to equal a negative 30. So now the equation of the line then is going to be 5x minus 30 when x is greater than 10. And then now it's just up to you to solve for the a and the b. So go ahead, set the equations equal, substitute in the 10, then do derivatives equal, substitute in the 10, and you shouldn't have a problem. And then the last one is number 38. Back to baseball. All right, 38. Baseball line drive. Milt Famey pitches his famous fastball. At time 0.5 seconds after Milt releases the ball, Joe Jamoke hits a line drive to center field. The distance in feet of the ball from home plate is given by the two rule functions shown below. And I'm going to write this down. And they give you the graph over here. Well, you can see the ball is starting out a little over 50 feet away from the plate. And if you think about it, this is the pitcher holding the ball. This part of the equation, because the ball is getting closer and closer and closer to home plate, it's at home plate, it gets hit, and then it takes off. So the two parts of the function are the pitch and the hit. So before the half a second's up, the ball's in flight from the pitcher to the batter. After the half a second, it's taken off from the batter, off the bat, and going. So the equations from the book: 60.5 times 0.5 minus t over 0.5 plus t, when t is less than or equal to 0.5. 150 times 2 minus 1 over t when t is greater than or equal to 0.5. Okay, so this part of the equation is the pitch. This part of the equation is the hit. And I would, because I know we're going to be doing derivatives, rewrite this 1 over t, bring this up, make it unhappy, call it t2 minus t to the negative first power. Then you won't have a quotient rule in there to worry about. Okay, what help do you need here? Okay, d prime, doing the derivative. Okay, that shouldn't be too bad. Well, maybe I should do that derivative with you. I think you can handle it. I guess I just wanted to explain the problem to you. Actually, no, I'll do the top derivative, you do the bottom. This one looks like it might be a little confusing. So d prime of t. So you do the derivative rule for each one of these separately. So for the top one, I've got a constant times, then this is a quotient rule. So this constant is going to get multiplied by the quotient rule. So the 60.5 is going to get multiplied by the quotient rule. So the quotient rule says take the derivative of the top, well that's 0, here's a negative 1, multiply by the bottom, minus, keep the top, derivative of the bottom is positive 1, not that I need that, all over the bottom squared. And then the bottom derivative, 150 times, and then in here we just have, because that's a constant multiplier, that's going to carry along. The derivative of 2 goes to 0, not needed. And then the derivative, oh, I want to use this one. The negative 1 comes down, that'll make it a positive. T to the 1 less power is negative 2. I could have distributed the 150 in there before I did derivative, and I'd come up with the same thing. That doesn't really matter. So this just simplifies to 1 distributing. 0 goes away, so that'll be 150 t to the negative 2. Okay, that's part A, doing the derivative. Then you can answer a couple questions on B and C. Okay, and C is asking for a limit as time approaches 0.5, but you got to look at approaching 0.5 from the left and from the right because it's two different equations. What's the limit as t approaches 0.5 from the right? So when I approach from the left, that's smaller than 0.5, you're looking at the pitch. So you're looking at the limit of the pitch here. So you're going to be putting the 0.5 into this equation, part of the equation. And then here you're looking for the limit as it approaches 0.5 from the right. That means values greater than 0.5 coming in. That's the limit of the hit. So you'll be putting 0.5 into this part of the equation. Okay, and you may have to, because you're probably going to get a 0 down here. Oh, no, you're going to be good. Okay, that's it. Your assignment then for this section is page 157, quickies 2 through 10 even, 22 to 30 even, 32 to 36, and finishing up 38. Okay, that's it.